Hello everyone, I'm going to knock out a few short and quick videos on just chapter 11. These are going to be examples. We did most of the discussions in class, and this mostly is to benefit my morning classes, which I hardly saw any of these past several days. Alright, so we're going to go and talk about tangent lines. Tangent lines in a circle is basically a line that comes along a circle and touches the circle in exactly one point. Not two, not three, but one. All right, so we have a tangent segment right here and a tangent segment right here. If they originate from the same point, we have a definition where these two guys are going to be equal. So you see something like this. Don't think of the earlier one of the things that we learned about outside times whole is equal to outside times whole. We're going to just go ahead and set these two guys equal to each other. So it's just 2n minus 1 is equal to n plus 3. So we got n is equal to 4. All right, and then we would plug that in, of course, to get our geometry answer, and this would be 7, and this would be 7. Let's take a look at another property when we hit tangent lines, tangent segments or lines or whatever. Here we have a tangent originating from the same point here. So we know that these two segments right here from DA and DB are congruent. But one of the other properties is if we have center of circle C, this has to be the center, doesn't work if it's not. This therefore is a radius, so this is a radius. When you have a radius intersecting the exact same point as a tangent, that's going to form a 90-degree angle right here. So this is 90, that is 90. And let's just say we want to find some things. We want to find a few things. Let's say we want to find the central angle right here of BCA. We want to find this angle. A couple ways we can do it. The easiest one is, well, we know we have a quadrilateral. It kind of looks like a kite. It is. So we know that all the angles are going after 360. This one plus that one plus that one plus that one equal to 360. And we just go over here and go ahead and subtract from 360, or we can subtract from 180 actually. But 360 minus 90 minus 90 minus 42 gives me 138. And there's more than one way to do it. If we actually want to construct the whole kite, we could by doing an angle bisector right through here, cutting that in half, and so on. And since this is a central angle, we know this is 138 also, the measure of this arc BC. So arc, or AB, arc, measure of arc B, I can't talk, is equal to 138. So the measure of the major arc, AQR, where did R come from? AQB, is equal to 360 minus that. And that's all we do. We just do 360 minus 138. Okay? Which leads us to some further properties that you may explore in future classes on how these tangent lines work with circles, because guess what? This angle, and that angle adds up to 222. All right. So that's pretty much for tangent. This is the scope of what we're dealing with this week. Again, in your future classes, you're going to dive a lot more into tangents and circles and curves. We just want to get you familiar with the vocab and assimilate you to some of the terminology. Alrighty, that's it for this one.